This is a multiple choice practice for an AP chemistry test using no calculators. We are going to try to show the work that is needed, but you are not graded on your work, so you show as much as you need to get to the answers. These answer choices are A through E, but the current format is only A through D, so this is actually even harder than what we'll see. So let's see how we can make our calculations without using a calculator, using a variety of different problems. So our first problem, they give you an equation, and then they give you some moles. So it says 0.60 moles of CS2 reacts as completely as possible with 1.5 moles of O2, according to the equation above. The total number of moles of the reaction products is blank. So it's important to organize your information. Throughout this, my blue writing is going to be the work I would actually show. My red is additional thoughts and ideas that I might have that might help you a little bit. So immediately what I would do is I would write down what I have, okay? And those are my products, or my reactants and the amounts that I have. I am looking for the total of those two. So this looks like a limiting reactant problem. So what I can do is simply compare one to the other. Okay, now this is technically moles of O2, moles of CS2, right? That's what I'm thinking about. But I have 1.8, okay? And what does that mean? I have 1.8 moles of O2 needed. Well, if you guys look at that, I only have 1.5. So oxygen is my limiting reactant. So 1.5 is how many I need to use. So now all I need to do is convert it to my two products. So again, what I'm doing is this is for the CO2 and this is for the SO2. And the 3 comes from my oxygen. Okay, so if you just go through this, that'd be 0.5 moles, and this would be 1.0 moles. So my final total is 1.5 moles. And there's my answer. So using stoichiometry, show as much as you need. Just make sure that you're keeping track of what the numbers have for values. Okay, let's take a look at the next problem. This one says at approximately what temperature will 40 grams of argon gas at 2 atm occupy a volume of 22.4 liters? Okay, there is multiple ways to go about this, but they gave me a pressure, they gave me a volume, they want to know temp. So right there, this looks a lot like an ideal gas law. So if I rearrange it, it'll be PV over NR. So the one confusing part is my 40 grams. If you look at the periodic table, the molar mass of argon is 39.9 grams per mole. So this is really, really nice. So basically, I have 1 mole. They're going to do that. They're going to make molar masses very, very convenient for you. So all I need to do is plug this in. So I have 2.0, I have 22.4 liters, I have approximately 1 mole, and now here we go. It's ATM, so this is my R value. I'm going to round that to 0.1. Whenever you have 0.0821, round that to 0.1. Again, I understand I don't have units. I understand that I'm not writing this all out, but I'm trying to show the work that I need to get to my multiple choice answers. So I get 44.8 on the top, and I get 0.1 on the bottom. Most AP questions are going to make you multiply or divide by 0.1. So this is going to come out to 448. So you look at your answer choices, and none of them are 448. So is it 270 or 550? If you were a betting person, you'd pick just the closest answer. But please understand that this number is actually a little smaller. So the smaller that is, because it's 0.0821, this would cause this answer to get a little bigger. So my answer would really make sense that it's 550 Kelvin. Okay. This is a pH problem, and pH problems give students a lot of difficulties when they're not allowed to use a calculator. So you need to have some data in your head. You need to understand a little bit about the math, that if you have a whole number for a pH, that comes out really clean to a number that's in scientific notation. So this says that I have a pH of 11.5, and I want to know the concentration of OH. So what I want first is I want POH. All right, so if I have that, that's going to help me. Okay, so This is something that I know. I know that POH equals negative log of OH minus. So if it wants the concentration, then this is something that I would need to determine. The problem is I can't do the math for that. I can't do 10 to the negative 2.5. But what I can do is I can do 10 to the negative 2 and 10 to the negative 3. And the reason why is that that gives me this value, and this one gives me this value. So I know that it's in between these two numbers. So if I look at my problems here, the closest value, the one that's in between, is 3.2 times 10 to the negative third. That is climbing up towards the 1 times 10 to the negative second, and that is in between those two values. So that's how you could do a pH problem, is make them whole numbers, and then you estimate to get to your final answer. This one says, what is the mass of copper that would be produced if 0.4 moles of Cu2O was reduced completely with excess H2? Okay, once in a while, you will need to know an equation. So it's saying that copper is produced. So what you need to do is talk about the copper 1 oxide is reacting with excess hydrogen. Okay, and that's going to make your copper. So then if you have copper, if you're looking at this, it kind of looks like a single replacement reaction, that you have all water. And you want to make sure that you balance this. And in this case, you would just need 2 for your copper. So I want to organize my information still. So I'm going to do this quickly. I get a minute and a half to do every problem. So the ones that deal with math might take me a little longer. So now this is just stoichiometry. Let's look at that without using a calculator, though. So I'm at moles of Cu2O. Okay, mole ratio, 1 to a 2. Okay, and then I'm going 1 here, and then I look up the molar mass of Cu, and that's 63.5. Again, red is just my thought process. This is moles of Cu. This is moles of Cu2O, right? This is grams of Cu, moles of Cu. But I wouldn't write any of that. I'm just getting the information that I need. All right, so check this out. If I take this right here, if you're struggling with math, 0.4 times 2 is 0.8. So what is basically 80%, because that's 0.8, of 63.5. So it's a little less than 63.5. And if I take a look, it makes sense that the answer is 51. It seems like it's about 80% of 63.5. So that's how we do some stoichiometry without using a calculator. Here's another problem that is also dealing with stoichiometry. It says when a 1.25 gram sample of limestone was dissolved in acid, 0.44 grams of CO2 was generated. If the rock contained no carbonate other than CaCO3, what was the percent of CaCO3 by mass in the limestone? This can get confusing, but what happens is that basically the carbonate broke down into this. So the carbonate, all of that, it's all a 1 to 1 to 1. So all of that carbon came from the carbonate. Okay, so if it's saying that 0.44 grams of CO2 came out, I want to know how many grams of CaCO3 did I have to begin with. So this is another stoichiometry problem. Let me show you what they do with molar masses to make this so easy for you. So you are going to find the molar mass of carbon dioxide, which is 44. Okay, that's 1 mole. Again, this is grams of CO2. This is grams of CO2, moles of CO2. Again, red is just my thought process. Okay, then I'm going from one to the other. These are just 1 to 1 ratio. And then I got to add up my molar mass. This is about 40, about 12, and then 16 times 3 is 48. Well, lo and behold, it's not a coincidence. That's 100. So that is my T-chart without any labels, which is not nearly as visually stimulating, but take what I can get. So I have 0.44 divided by 44, all right? Basically, that's 0.01 divided by 100, and you get 1 gram. Well, the gram sample is 1.25. So I have that. I have 1 gram. And now you got to figure out the percentages. So 1 gram over 1.25 grams, well, that's 80%. If you're really struggling with that, think of it this way. There are four 1.25s, 4 quarters in 1 gram, and there's 5 quarters in 1.25. So that's 4/5. That's 80%. So that's how you would work out that problem. Finally, I wanted to do a problem that didn't require a calculator, just to reiterate that there are problems once in a while that they give you multiple options for multiple different questions. Usually they never repeat, but never underestimate the idea that it could. So this one, they're giving you different types of elements in the periodic table, or groups or families, and now we need to answer it. So number one, are the most difficult to oxidize in a given period of the periodic table? Well, that means oxidize is to lose an electron. To lose an electron, you become positive. Okay, so the one that is the most difficult would be a noble gas, because noble gases are very difficult to remove or to add any electrons to whatsoever. Number two, are always radioactive. The lower you go on the periodic table, the more radioactive the possibility. Well, the lowest period on the periodic table, the family are the actinides in the F block. So that is letter E. And finally, are the most likely to form anions, which are negative ions. So noble gases don't form anything, and alkali metals are positive, transition elements are positive, and actinides are positive, because those are all metals. They become positive cations. So the answer would be C. So whenever we're using a calculator, we need to make sure that we are estimating and we're showing the work that is needed, but we do not want to stress about labels and units due to the time frame that we are under for the multiple choice section on the AP chemistry test. Hope this helps you organize and calculate some of the more difficult multiple choice problems that you may encounter.